Okay, so I think we can start. Um, Let me test the. Oh, hang on. Hello. Same as system, says as system. Okay, how's the preparation? Everything is fine, right? I think nobody wears mask. Why do I wear mask? Okay, he wears the mask like me. So okay, preparation is fine, right? You understand what is coming in the exam? Yes, no. So let's do this problem. The problem says that you have to find the maximum stresses. Now, this is a little complicated problem. First of all, okay, we still have 2 minutes. We can wait for our students to join. Let me just start the solution. Number one is that I will try to find the maximum moment. So I suppose that I will have let's say summation of moment about point B equal to 0. Then I have positive 3.6 kilonewton into 1125 over 1000 into 1000, correct? Plus, oh come on, minus RA equal to 0. So RA comes out to be, I don't have a calculator. Okay, so AY as I want to call it, I will not use the word RA because there is horizontal force as well. So AY comes out to be, okay, you need to double check by the way. 2.7 kilonewton I am writing, but one of the students has to double check. I appreciate it. Thank you, Fahad.
Hocam, is this 3.6 times 1000 or
minus? Oh, sorry. Yes.
is that supposed to be over 1000?
Yeah, let me double check. So this is 375 millimeter and this is 1125. Let me double check whether 1125 is the total distance or not. Okay, Hafad can double check whether through this equation we are getting AY or not. No? Okay, so sure.
We're getting 4050.
Okay, so please, can you double check with this one now? 1125 minus 375. I think
Yes.
then we get the answer. Okay, so hang on. Why don't you write 1125 as the total? Thank you. Okay. Thank you for the help. Okay, and now you can ask the question. I think you were asking the question.
And the others is to the diet found 405.
Yeah, okay. So I was making the mistake. And 1125 minus 375 is, if you can give me the number for our student. 750? Sure.
AY is the force or moment?
AY is a force.
That's a force and where.
Oh, sorry. Minus AY into. Yeah, sorry. Minus AY into.
Then we don't get.
Moments it has to be starts.
Okay. Yeah, like this.
But if you multiply this.
Yeah, I have multiplied. How far I have
The
multiplied?
answer changes.
Tell me the answer.
Over 24.
Oh, okay. Sorry. Hang on. I'm sorry. Then the 1125 was that one. Okay, do it again. I am not sure about how I mentioned the dimension, so that's why I'm struggling. I'm sorry. Oh, hang on. Let me do it once and for all. Plus 3.6 kilonewton into 1120. Hang on. Minus AY into 1125 plus 375. Okay.
Yes.
Sure, 100%. Okay, so please remember 1125 starts from 3.6 all the way up to here, and 375 is this portion. I'm sorry for the confusion. I was not sure what about the dimensions on my notes. So now that you have got minus AY into 1125 plus 375 plus 3.6 into this, you got a value of AY. Now,
Did you multiply on 1125 plus 375 with AY?
yeah, of course.
Ah.
There is a bracket here. Absolutely. You are 100% correct. Sorry,
Where does that come from? 1125.
this is 1125 and this is
Oh,
375.
okay.
So now I have BY equal to AY plus BY equal to this value. So BY comes out to be,
Screen is down.
I know, BY comes out to be 0.9 kilonewton.
Sir, what is the topic?
I will tell you. 0.9 kilonewton means 900. The name of the topic is combined loading. Okay, now that you have got this, now give me the value of stresses. So I will say AX plus BX, let's say AX plus BX, let's say, equal to 25 kilonewton, I suppose. No, I'm sorry, not BX. Forgive me. AX equal AX, sorry, plus 25, because BX does not exist. There is a roller. I apologize. AX plus 25 kilonewton equal to 0, and AX comes out to be negative 25 kilonewton, which is minus 25,000 Newton. This means we have, ask me any question. What was his question? No? Okay. Now I will make another drawing just to emphasize the free body diagram, because our students are getting confused what is happening. So this is what I try to do. There will be a 25 kilonewton here. There is a 25 kilonewton here. Agreed? Okay. Now give me the value of stress X. Okay, Marish can also help us. Stress X comes out to be force per unit area. You asked me the name of the topic. You have to understand. When you are putting a load from the top, what will happen? There are bending stresses, right? Because there is flexure. There will be bending stresses. But on top of that, somebody is also putting a load in the axial direction. So you will have two components to the overall stress. One component will come from the bending. One component will come from a direct stress of F over A. Are you getting a feel of the, because real life problems are combined loading. You don't have a, how on earth can you create a simple loading problem on your own? Okay, give me the answer. And by the way, students who have just joined us, students also helped us in identifying this portion is 1125 and this portion is 375. I really appreciate, by the way. Now stress X comes out to be 25 into 1000. Marriage is with us. Let me hang on, please, everyone. Divided by, what is area? Area, okay. Oh, well, I will provide you the area. That's my mistake. This is the area, by the way. So area is nice and beautiful. 50 by 75. with a nice and beautiful neutral axis. Okay. Okay. Now area becomes 50 multiplied by 75. Okay. Divided by 1000 square. Okay. So I get a value of, use the calculator, give me the value. .75 into 10 power 6 pascals. Okay. Okay, very nice. Now, where is this stress acting? Well, that's the value of average stress. Are you getting my point? So students who are still getting confused, what on earth is happening? I will create for this direct stress a beautiful drawing that all the arrows are happening like this. This is axial. Are you getting my point or not? Okay. Okay. So I will finish the rectangle like this. So these are my direct stresses that are acting over the whole cross section. Okay. I will call it as 6.75 megapascals of DIRECT STRESS. Now give me the bending stress. Use the imagination, you have sufficient background. Give me the bending stresses, maximum bending stress, compressive as well as tensile, okay? Okay, so students who are trying to do it, they will get confused because all of them are asking, what is the maximum bending moment? So what is the maximum bending moment? It will be minus AY into 0.375. Go back to your statics background, create a nice and beautiful bending moment diagram. In that bending moment diagram, there will be a maximum bending moment. Identify it. That's not my problem. You have to go over it yourself. Revise your statics. But I think looking at this diagram, it is pretty obvious that the maximum bending moment will happen where the load is acting. So minus AY into 0.375 plus M equal to 0, and M comes out to be, give me the value. I hope everyone is not feeling lost. You are getting a feel of the problem, right? Because usually I would have given you, like previous examples, the value of maximum bending moment. Now I am not even telling you maximum bending moment. You find it yourself. Okay. What? Don't hesitate. There can be a mistake here. Tell me.
No, I'm just.
Okay. Okay. So since no one is giving me the value, I will just write it from my notes. My notes say
1012.2.
Seems reasonable. 1.013 is in my notes. Very nice. Thank you. Appreciated. 1.013 kilonewton meter. So I suppose I can write Newton meter. Okay. Okay. Now we will finish the question by saying
We need to find
Of course. Yeah, that is something that is, but you are right in pointing out. So stress X equal to minus mzy over iz. Oh, come on, I have to use another marker, which is equal to minus 1013, as one of the students has helped us. Y value is
75/2.
very nice. How did you figure? Because the object will bend like this. Good answer, by the way. Divided by Iz, and Iz, as you said, it is very important. So I suppose it will be 50 into 75 power 3 divided by 12. So I will do a 50 into 75 power 3 divided by 12, and then I convert it into meter. So I will put a divided by 1000. You do it yourself. 50 into 75 power 3 divided by 12.
What about 75 divided by 2? Doesn't that need conversion as well?
Yeah, very good point by our another student. I again forgot. Thank you. So then stress X comes out to be
21.6.
21.6. Seems reasonable. Minus mega. Okay. What about the maximum tensile stress then? I suppose for this symmetrical structure it will be positive. You use MC over I don't know. It's entirely your job. Okay, let me ask Marij, Dogukan, and Ehsan. Are they with us? Okay. Marij said yes. So are you understanding that there is a axial load acting as well? So this is a combined loading problem. Okay.
For minus AY times 0.375 plus N equals 0 job. Doing
Where?
slightly
This one?
wrong job, the upper part.
This one?
We're finding moments. Yeah. So we are doing like this, right? We go like this, and we.
Find it at 3.6. You are talking about this one, right?
This is
Minus AY into 0.375 plus M equal to 0. We cut it from here and we throw this chunk away, yeah?
We are not including 3.6.
No, of course not. Of course not. If you want to include this, you will have to cut it from here, here, or here.
After the 3.6, the force, the V we talked about, will be decreased, right? Because it becomes.
Yeah, but I'm not talking about V right now. You have to make bending moment and shear diagram. That's the bottom line. You have to go over it. I am just finding the maximum bending moment by observation. Okay, did everyone do it? Okay, everyone. Thank you. And
Just on tensile stress is positive. I'm asking.
compressive is negative and tensile is positive. Where it is acting, that's another thing. You have to make observation. So, for example, in this particular problem, when the load is acting from here, for me, when I talk about maximum tensile bending stress or maximum compressive bending stress, compressive is acting on the top fiber. But you have to understand, when you write here maximum tensile bending, maximum compressive bending, right now we cannot just use the word maximum or compressive, or I will tell you the reason. Look, you have to combine both the chunks together. Are you following me? So this is the direct stress that you calculated. Are you following me or not?
Yes.
We have Bahadur who has joined us. So this is your direct stress that all of you calculated. And then now you have bending stress, something like this. Okay, and one of the students has to, I request, okay, thank you. So we will, oh, I think the length of the line, I have to be a little careful now. And now I will put a fellow like this, and I will put a fellow like this. Boom, neutral axis right at the center because my structure was symmetrical about the x-axis. Now this is your bending. What was the value? 21.6 megapascals, as one of the students told us. This is positive 21.6 megapascal maximum tensile bending stress. So you will start making nice and beautiful arrows. By the way, you have to see your textbook. Every time I make the direction of this arrow, you once and for all open the textbook and see how the author makes the direction of these arrows. When I make these arrows, you know what I do is I say, if this line is my center line, then if it's in bending, then the arrows go like this. And in the bottom surface, the arrows go like this. This is how I make the diagram. I'm not sure how this author, because in one of the diagrams I was seeing the author put it differently. So just once and for all, open your textbooks after the class and get this sorted out. So as I said, my methodology is, this is the arrow, this is the arrow, this is the arrow, this is the arrow, this is the, no, 1 minute. It goes like this. So yeah, that's why I'm telling you, the author sometimes flips the arrows. So this is your compressive, this is tensile. Because for me, this line is where this is compressive and here it is tensile, and this is the center line. That's why this arrow is like this. And that's why this arrow is like this. Okay. Now you combine the two together. Okay. Now when you combine the two together, 1 minute. Yes. What will happen? Why don't you help me? Use your imagination and tell me what will happen. Ebu, what is your thought process? If this is 6.75 megapascal, then why don't you help us? I suppose this one will become less, no? So 6.75 minus 21.6 will give me 14.9, I suppose. Okay. So 14.9 megapascals. Okay, our students are getting confused, so I will explain them. 25 kilonewton is acting like this, right? On the top surface, the compressive stresses are like this. So 25 kilonewton and the compressive stress will act against each other, and they will try to reduce each other's effect. That's why you have got like this. On the contrary, when you go through this is your neutral axis. You can see, okay, I suppose I could not do a very good job. So you know what, I will try to use the fact that I have this whiteboard. Now you can see when the load, somebody is pulling this fellow 25 kilonewton to the right, the bottom surface is under tensile, it's stretching. So that 25 and that stretching kind of a thing will add together. And that's why you will get a big quantity, no? Okay. Oh, this diagram doesn't, unfortunately. Oh, I think the neutral axis is wrong now. I'm so sorry, because 6.75 megapascal direct stress will still go through the neutral axis. I apologize. That's why I was making this mistake. Thank you. Everyone is since observing. That's why there is no room for mistake. Okay, now I can. Something like this. Okay. And now, left and right, but I have arrived at what I wanted. Correct. So this value is how much? 28.5 megapascals. And this value is 6.75 megapascal. So you can see how big of a mistake I ended up making. Where there is a neutral axis, you still have a stress. What stress? Coming from the direct stress, because the bending stress is not available on neutral axis. But because of your direct stress, there is a value that showed up. Any questions for me? Yes, I will. Please ask me the question.
Directions are opposite in tension with the direct stress.
Yeah, that's why I'm telling you this. You have to open the textbook for that. No, so I look at like this. You put a load over this. The fibers below the neutral axis, they are in tension. The top surface or the upper surfaces are in compression. Yeah, so when I'm putting a load of whatever that value was to the right, that kind of minimizes the effect of the compressive, while that exacerbates the effect of the. So you just look at this diagram and have a look at it. 25 kilonewton, 3.6 acting like this. So 25 kind of counters the effect of compressive because the surface is going like this, whereas the surface tends to expand like this. So this 25 kilonewton minimizes the effect of compressive, exacerbates the effect of tensile. That's why your values are less on the top and more on the bottom. Okay, any questions from, let's say, Marich or Ehsan or Bahadur or Dogukan? Okay. Oh, nobody replied. Okay, I think Marich replied, Bahadur replied. Ebu, this is clear, right? Sure. Okay. If this is clear, then why don't you all solve this problem? Use your imagination. This is going to be a hard problem. Okay. This is very hard, by the way. In the last semester's final exam, I gave this problem, by the way. This is a difficult problem. It takes a lot of thinking. Okay. First of all, go step by step. You don't just start the problem. First, go over the thought process. What this problem is that when you're putting the load of 250 Newton in this particular direction, what happens? The number one thing that would happen is that this whole object tends to bend. You see that light blue lines and arrows that I created? I'm just trying to tell you how the bending will happen. Okay, we have 2 points of interest. I'm asking you to give me the value of stresses at A and the value of stresses at B. Now, what you have to understand is that this problem has a problem. Number one, when you're putting a load in 250 Newton direction, just focus on point A. That's why I'm not starting to solve the problem. Okay, if you focus on point A, what will happen? Because of the bending effect, this is a rectangle. You can see the beautiful green section I showed on the right. So A will become, So the A lies on the neutral axis. Because of the bending, you will not have any stress. But the fact that 250 Newton will have a projection in the x-axis, like 200 Newton, I have made a projection as well. Angle is given to us. Acha, yes. So 200 Newton will act as a direct stress at A. But the problem doesn't end here. There is another facet to it. What is that? A has something else. Think about it. Bending you talked about, direct you talked about, anything else? What will have A? Moment. I talked about moment creates the bending. Direct stress, bending stress, anything else? Online students. Bahadur, Marich, Dogu Khan. Huh?
I mean, the force is angle, so yeah, they will go again.
Yeah.
Direct stress and-
I said direct stress, bending, anything else?
Shear stress.
Very good. Very good. Shear stress, the topic we have been studying, shear stress. So we will have now shear stress as well. What was the formula? VQ over, look at your notes. VQ over, I remember the formula, by the way, I just want you to flip the notes. VQ over, What about B? Focus on the point B. Tell me how many stresses are there. In an exam setting, if I give you the students who identify the kind of stresses, I give them points, by the way. Okay, at B, you will have a direct stress. Then you will have a compressive bending stress. Anything else? Sure. Okay, think about it. On surface, huh?
If shear force acts in A, then it should act in B as well.
Longitudinal shear are you talking about?
Yes,
Longitudinal shear, the one that we were talking about. You think point B will have a longitudinal shear?
I think.
Okay. Did we talk about in last class on a free surface there is no longitudinal shear? Do you remember? Does it ring bells? So we used to find Q. Remember? So when we used to draw a line, you used to find what was that? Y bar A. And if you keep on going away from the neutral axis, you arrive at the surface. Free surface does not have any shear. In fact, this is very understandable, right? Free surface does not have any, unless I do like this. Unless I do like this, well, free surface, what shear? Okay, very good. Now our students, I think, understand the problem statement. So why don't you give me the answers? Solution.
So there are some people-
Please, why not?
Where is the shear stress acting?
Longitudinal shear X happens at A. So for example, when you're trying to put a load like this whole object bends, right? So when this whole object bends, there are fibers inside it, right? So each fiber on top of other fiber, they have shear, longitudinal shear that we were calculating in this class just 2 days before. What I am trying to tell him and the whole class that A will have a longitudinal shear, point B will not have a longitudinal shear. Why? Because point B is the free surface. Okay, now I will create the final answers. The section properties are given to me by the problem. This is 0.5 inches and this is 0.75 inches. Again, sorry, you have to bear with it because this problem is British units. So area comes out to be 0.375 inch square. I multiplied the two. And the moment of inertia our students are trying to calculate. That will be BH cube over 12, which will be 0.75 into 0.5 power 3 over 12. Why? Because the object bends like this. And when it bends like this, B will be 0.75. This comes out to be 0.0078125 inch power. Okay, give me the direct stresses, give me the bending stresses. I'm going to load table as well. Give me the bending stress. Stress is equal to m by over I. Use the imagination. And by the way, when you're finding the moment, find it where? Whatever happens, this is a complicated point. I'll have to tell it in the recording. Okay, it becomes very complicated when, because students tend to sometimes get confused. Yeah, I will take your question. Just 1 second. When you're trying to find the moment, where would you find the moment? When you're talking about the maximum bending stress at B, you will find the bending moment at the neutral axis. So for example, don't add or subtract that little length. I will explain when I do. You are trying to find the bending moment at B. When you are trying to find the moment M, you will just find it on the centroidal line. Okay. Yes, please.
John, does moment is 300 Newton each? The moment.
I will explain. Okay. I will answer your question like this. So stress AX is equal to. Okay, let's do it together. It will be like this. So it will be N over A minus My over Iz, and our students will stop me. They will say, what do you mean by this? And I will put a 0. So it becomes N over A. Oh, come on. So it will be 200 divided by 0.375, which is equal to, I don't know, you will help me. By the way, did I give you the units? This is not Newton, please forgive me. This is pound force, of course, LBF or LB, if you want to call it. I would appreciate if you can please give me the answer. No, I have the answer, sorry. 533 I have in my notes. Next time I'm coming with my own calculator. My bag got lost and I'm pretty dejected by it. Huh? Say again?
Why is Y0?
It's on the neutral axis. Bending stress is 0 on the neutral axis.
What is on the neutral?
Of course, because this is a rectangle. Look at the green section. And I'm putting a load, the whole thing bends. So if the whole thing bends, big deal. I cannot put any bending stress because the A is sitting on the neutral fiber. Okay. So why don't you all help me with the stress Bx? Let me ask our online students. Ehsan, Bahadur, Dogukan, Marij. So I will be waiting for your answer, by the way. Whoever gives me the right answer, then of course I will be happy. Why don't you give me this value, huh? Try it, Marij and Bahadur and everyone else. Hafad, Abdullah and Hamza and Ibu and Mehmet. Huh?
When you move them.
Yeah, I will.
For finding the M.
So finding the M
For finding the M.
bending moment. Let's do it.
Neglecting the distance from the wall at A, right? Not looking at that part.
You will find the bending moment about the centroidal line. Don't try to find, don't subtract this little distance. I keep on saying again and again, it becomes very tempting that when you are trying to find the bending moment, well, I am talking about point B, right? So all of you will say, why don't you focus on B? I am focusing on B. But when you talk about any section of interest, you just find the moment about the centroidal line. I hope everyone is following me. I keep on emphasizing. Anyways, so stress Bx will become equal to 200. Everyone, 200 multiply by, what is the distance? 1.25 from here to here. You see, it becomes very tempting that you just subtract this little thing. Oh, battery is gone. Oh, I forgot to bring the charger. That's such a big mistake. Laptop is gonna close. Okay, you do it and then I will bring the charger.
And nobody might.
Branding,
Oh,